Hello, my name is Jeffrey Rosario, and I'm going to give a brief presentation on the use of deep learning with pneumonia classification. Now, what is the problem statement? Does the patient have pneumonia? And the goal is correct classification of patients with pneumonia. Now, how are we going to do this? We are going to do this with the use of chest X-rays. What would be the business value of this project? Well, if you have a high accuracy score or a recall score, you can package the software into a simple GUI, graphic user interface, and you can sell this to hospitals or healthcare software companies as a tool to assist doctors, nurse practitioners, and physicians. See, the human eye cannot see as well as a computer can discern the pixels of an image. This software can help reduce human error. Now, the dataset is comprised of around 5,800 chest X-rays of pediatric patients aged 1 to 5 from Guangzhou females. And we used a densely connected neural network with one input layer, two hidden layers, and one output layer for our baseline model. And we also used a convolutional neural network, which is used often for image recognition. And when data is scarce, we use data augmentation to generalize our data set. Data augmentation involves artificially producing different images by zooming, shrinking, flipping, and any other sort of augmentations you can do to an image. Let's take a look at our data. These are the images that were produced after data augmentation. This helps generalize a model so as not to overfit to the training data. The first image shows a slight shift to the left. The second image has a slight zoom. On the left, we have a pneumonia patient, and on the right, we have a normal patient. Doctors are trained to determine whether a patient has pneumonia with a series of tests, such as checking bacterial culture and possibly looking at chest X-rays. Now let's check the balance of our data. Here we have a graph depicting the count of pneumonia versus normal chest X-rays. And as we can see, there's about a 3-to-1 ratio of pneumonia to normal patients. We will account for this class imbalance when we do create our model. So after creating our model, we want our final model. We will skip straight to the final model. Here we are going to check the model accuracy using a confusion matrix. Here we have two confusion matrices. The left confusion matrix is a normalized version of the right confusion matrix. And in the confusion matrix, the top left is the true positive rate. The top right is the false positive rate. Bottom left is false negative. Bottom right is true negative. So to interpret this confusion matrix, you can say on the top right, with 14%, 14% of normal cases were classified as pneumonia. And on the bottom right, you can see 96% of pneumonia cases were classified as actually having pneumonia. And on the bottom left, we have 3% of patients with pneumonia were classified as normal, which is a very low rate, low false negative rate. So our findings are that the convolutional neural networks may successfully classify pneumonia. The model produced a 96% recall for positive pneumonia with an overall accuracy of 93%. Now, for our future work, we would like to implement grid search to try different parameters. Also, the dataset was somewhat limited since we only had the patients were women aged 1 to 5 in Guangzhou, China. We may want to also try to classify whether the pneumonia is bacterial or viral. Thank you very much.